So now that we've broken down the components of the aggregate expenditures, we now look more closely at macroeconomic equilibrium. So earlier we saw that macroeconomic equilibrium occurs when GDP is equal to the aggregate expenditure. So we can use a graph called a 45-degree line diagram to illustrate the macroeconomic equilibrium. Sometimes we call the 45-degree line diagram the Keynesian cross because it's based on the analysis from John Maynard Keynes. So let's suppose the entire economy, there's one single product, Pepsi. For the Pepsi economy to be in equilibrium, the amount of Pepsi produced has to equal the amount of Pepsi sold. Otherwise, we'll see inventories of Pepsi rise or fall, which by definition means that we're not in equilibrium. So here we have an example of a 45-degree line diagram. So the line on the diagram forms the angle of 45 degrees of the horizontal axis, which is why we call it the 45 degree. The line represents all the points that are equal distances from both axes. So points like A and B, where the number of products equals the number of products sold, are on that 45-degree line. So the economy's inventories of Pepsi are equal to the quantity sold of Pepsi at A and B, and anywhere on that 45-degree line. Anywhere off of that line, the economy is not in equilibrium. So for instance, at point C, the economy's inventories of Pepsi are being depleted. So in this case, production has to rise to restore equilibrium. And at point D, inventories of Pepsi are growing, so the production is going to fall. So we can apply this simple model that we used for just an economy made up of Pepsi to the real economy. So we'll have real national income, or GDP, on the x-axis, and real aggregate expenditures on the y-axis. So this is what we're calling the Keynesian cross. Now, only points on this 45-degree line are going to be macroeconomic equilibrium, where the planned aggregate expenditure is equal to GDP. If you're below that 45-degree line, the planned aggregate expenditure is less than GDP. And if you're above that line, that 45-degree line, the planned aggregate expenditure is greater than GDP for all these points. So changes in GDP have a much greater effect on consumption than on planned investment, government purchases, or net exports. So for simplicity, we assume that changes in GDP have no effect on planned investments, government purchases, or net exports for this simple model we're working with. We're also going to assume that other variables that determine planned investment, so government purchases and net exports, are going to remain constant, as do variables other than GDP that affect consumption. So now let's try to determine the macroeconomic equilibrium. Any point on the 45-degree line could be an equilibrium, but how do we know which one is going to be the equilibrium in a given year? In order to determine this, recall that when they receive additional income, households consume some of it and they save some of it. Those are the two things that we see them doing with their additional income. So resulting consumption function tells us how much consumers will spend, their real expenditure, while they have a particular income, or real GDP. So this will determine the consumption in the equation y equals c plus I plus g plus nx. Now, macroeconomic equilibrium simply means that the left side, real GDP, that y, must equal the right side, the planned aggregate expenditure. So for that, the trick is to find the right level of c. And to do that, we're going to return to the 45-degree diagram. So let's start building this up using our 45-degree diagram. We're going to start by placing the consumption function on the diagram. Now, if there were no other expenditures in the economy, then the macroeconomic equilibrium would be where the consumption function crossed the 45-degree line. So at this point, that's where GDP is going to equal expenditures. But we're not going to stop there because there's other expenditures that are going on. While there's these other expenditures, we're going to assume that they're not affected by income. So basically, they're predetermined. So to this consumption function, we're going to add the other expenditures. So we'll add planned investments, which gives us the red line, C plus I. Then we'll add government purchases, which gives us the yellow line, C plus I plus G. And then finally, we'll add net exports, which will give us the light gray line, which is C plus I plus G plus NX. So these are going to be vertical shifts in the expenditure because their values don't depend on real GDP. So they're not going to have a slope like we saw with the consumption function. So once we add I plus G plus NX to the consumption function, we end up with our aggregate expenditures. And remember, the Y on the 45-degree line is also going to equal aggregate expenditures. So our point of macroeconomic equilibrium is going to be where the C plus I plus G plus NX equals Y, where it crosses that 45-degree line. So we're going to call this top line the Y equals C plus I plus G plus NX. That's going to be our aggregate expenditure function because it includes all of the components of the aggregate expenditure. And again, our equilibrium point for the entire macroeconomy is going to be where that line crosses the 45-degree line. Now let's use figure 12.11 to make this relationship a little bit more clear. And we'll do that by only showing the 45-degree line and the aggregate expenditure line. So the sum of consumption, investment, government spending, and net exports. So we only have to work with one line and not clutter up the diagram. So in this case, the figure shows that the aggregate expenditure line intersects the 45-degree line at the level of real GDP of $10 trillion. So because of that, $10 trillion represents the equilibrium level of real GDP. So consider a situation where GDP is only $8 trillion. What if this is the case? Whenever total spending is greater than the total production, firms' inventories are going to fall. The fall in inventories is going to be equal to the vertical distance between the aggregate expenditure line, which shows the total level of spending, and the 45-degree line, which shows the $8 trillion of total production. So unplanned declines in inventories are going to lead firms to increase their production. As real GDP increases from $8 trillion, so will income, and therefore so will consumption. So the economy is going to move up the aggregate expenditure line as consumption increases. And the gap between the total spending and total production is going to fall. But as long as the aggregate expenditure line is above the 45-degree line, inventories will continue to decline, and firms will continue to expand production. It's only once real GDP rises to 10 trillion that inventories stop falling, and the economy has reached macroeconomic equilibrium. So notice that the macroeconomic equilibrium can occur at any point on the 45-degree line. Ideally, equilibrium is going to occur at the potential GDP. At potential GDP, firms will be operating at their normal level of capacity, and the economy will be at the natural rate of unemployment. As we have seen, at the natural rate of unemployment, the economy will be at full employment. Everyone in the labor force who wants a job will have one, except for those workers who are structurally or frictionally unemployed. This goes back to Chapter 9 when we talked about the different types of unemployment. However, for equilibrium to occur at potential GDP, planned aggregate expenditure must be high enough. And as we see in the figure here, if there's insufficient total spending, equilibrium will occur at a lower level of real GDP. In this situation, many firms will be operating below their normal capacity, and the unemployment rate will be above the natural rate of unemployment. So let's look through an example to try to understand this. Suppose that the level of potential GDP is $10 trillion. As figure 12.12 shows, when GDP is $10 trillion, the planned aggregate expenditure is below the $10 trillion. Perhaps because firms have become pessimistic about their future profitability, so they reduce their investment spending. The shortfall in planned aggregate expenditure that leads to the recession can be measured as the vertical distance between the aggregate expenditure line and the 45-degree line at the level of potential GDP. The shortfall in planned aggregate expenditure is exactly equal to the unplanned increase in inventories that would occur if the economy were initially at level of GDP of 10 trillion. The unplanned increase in inventories measures the amount by which current planned aggregate expenditure is too low for the current level of production to be the equilibrium level. In other words, if any of the four components of aggregate expenditure increase by this amount, the aggregate expenditure line would shift upwards and intersect the 45-degree line at the GDP of 10 trillion. And then the economy would be in macroeconomic equilibrium at full employment. So what we see in figure 12.12 is the macroeconomic equilibrium will occur when real GDP is 9.8 trillion. Because the real GDP is 2% below the potential GDP of 10 trillion, many firms will be operating below their normal capacity. And what we'll see with the unemployment rate is it'll be well above the natural rate of unemployment. And the economy will remain at this level of real GDP until we see an increase in one or more of the components of the aggregate expenditure. Now, inventories play a critical role in this model of the economy. Whenever planned aggregate expenditure is less than real GDP, some firms are going to experience unplanned increases in inventories. So, even if spending returns to normal levels, firms will have excess inventories to sell. And they will do this instead of increasing production to normal levels. So we're not going to see the economy recover as rapidly because they have these inventories that they're going to sell down before they begin hiring new workers. So for example, more than half of the sharp 5.4% annual rate of decline in real GDP during the first quarter of 2009, during that recession, was a result of firms cutting production as they sold off unintended accumulation of inventories. These inventories they didn't plan to have. Economists estimate that half of the decline was due to firms cutting production. Now this table, 12.3, shows several hypothetical combinations of real GDP and planned aggregate expenditures. Now when economists are forecasting real GDP, they rely on these quantitative models of the economy. So by exploring this table, we can increase our understanding of the causes of changes in real GDP by considering this simple numerical example. So even though this is simplified, it's going to capture some of the key features that we've explained on the previous slides for the quantitative models that economic forecasters use. So the first column we have here lists real GDP. And the next four columns are going to list levels of the four components of planned aggregate expenditures that occur at the corresponding levels of real GDP. So we're going to assume that planned investment, government purchases, and net exports do not change as real GDP changes. So first let's look at the look at the first row of the table. Where GDP equals 8,000 billion, or $8 trillion. So what this is going to do is result in consumption of $6,200 billion. So when we add consumption, planned investment, government purchases, and net exports across the row, that's going to give us the planned aggregate expenditure of $8,700 billion, which is what we see in the sixth column here. Planned aggregate expenditures. Because planned aggregate expenditure is greater than GDP in this case, it's greater by $700 billion. Inventories are going to fall by $700 billion. Now this unplanned decline in inventories is going to lead firms to increase their production. And what this is going to do is increase GDP as these firms begin to produce more. So GDP is going to continue to increase until we reach that $10,000 billion mark. At that point, we're in equilibrium and there's zero unplanned changes in inventories. So there's nothing encouraging firms to increase or decrease their production. So we're going to stay here at this equilibrium level. Now let's look at the last row. Let's say the GDP is $12,000 billion. What's going to happen here is we're going to have consumption of $8,800 billion. So the total planned aggregate expenditures, when we add up consumption, planned investment, government purchases, and net exports, is going to be $11,300 billion. So because our planned aggregate expenditure is less than GDP, inventories are going to increase by $700 billion. There's going to be, some goods left over in inventories. Now this unplanned increase in inventories
is going to lead firms to decrease their production. Because there's these extra goods they have in inventories that they weren't expecting to have, that they still need to sell, they're going to decrease their production in the next period so they can sell off those in the inventories first. What this is going to do is decrease GDP. GDP is going to continue to decrease until it reaches that 10,000 billion, till it reaches our equilibrium quantity or equilibrium GDP again. At that point, the unplanned changes in GDP are going to be zero, and the economy is going to return to macroeconomic equilibrium. And at this point, there's no unplanned inventories to change firms' production decisions. So only when real GDP equals $10,000 billion in this example will the economy be in macroeconomic equilibrium. At any other level of real GDP, whether you're above the equilibrium or below the equilibrium, the planned aggregate expenditures will be higher or lower than GDP, so the economy will be expanding or will be contracting. Now we're going to turn to section 12.4, the multiplier effect. In a previous example, you might have noticed that a small change in the planned aggregate expenditure caused a large change in equilibrium real GDP. So in this section, what we're going to do is look more closely at the effects of a change in aggregate expenditure on the equilibrium real GDP. In our model, remember, planned investment, government purchases, and net exports are autonomous expenditures. And what we mean by that is that their level doesn't depend on the level of GDP. These are determined by factors outside of what determines the level of GDP. But for consumption, for that portion of GDP, that's going to have an autonomous and an induced effect. So some of it is going to come from the amount that's being purchased in the previous period, and the GDP in the previous period, and some of it is going to come from outside of, from other things. So level of consumption does depend on the level of GDP. So this is going to produce the upward sloping aggregate expenditure line that we're going to work with throughout this section. We have figure 12.3. This is our simple Keynesian cross that we worked with in the previous section. So we can use this to illustrate the effect of an increase in planned investment on investment spending. So let's assume that the economy starts in equilibrium here at point A, where the y equals AE, that 45-degree curve, crosses the aggregate expenditure curve. It's going to cross at point A, where the real aggregate expenditure is $9.6 trillion, and the real GDP is $9.6 trillion. Let's say firms then become more optimistic about the future profitability of investment. So what they do is they increase spending on factories, machinery, and equipment, things like that, by $100 billion. So they increase their investments. This increase in investment spending is going to shift the aggregate expenditure line up by $100 billion. So we'll move from the line AE1 in the figure on the right to AE2. The new equilibrium occurs at point B, which is where real GDP equals $10 trillion, which equals the potential real GDP. Now, what's important here, and what I want you to notice, is that the $100 billion increase in the planned investment spending results in a $400 billion increase in equilibrium real GDP. So the investment spending has a multiplied effect on the equilibrium real GDP. Now, in practice, it's not just investment spending. That's not the only component of GDP that's going to have this multiplied effect. Any increase in autonomous expenditure is going to shift up the aggregate expenditure function and lead to a multiplied increase in real GDP. So because we had this line shift up from AE1 to AE2, we see a greater increase in real GDP than in the actual investment going into it. And like I just said, it's not just going to be for investment. Any autonomous expenditure is going to cause this multiplied effect. So in this case, $1 of increased spending is resulting in $4 of increased real GDP. So this is a real large effect that we're getting. By spending $1, you can increase GDP by $4. So the ratio of the increase in equilibrium real GDP to the increase in the autonomous expenditure, that's called the multiplier. The series of induced increases in consumption spending, that results from an initial increase in autonomous expenditure is called the multiplier effect. So the multiplier effect is the process by which a change in the autonomous expenditure leads to a larger change in real GDP. All right, so let's work through what's actually happening and take an example to look at the multiplier effect in action. So let's suppose the $100 billion of increased investment in the previous example on the last two slides consists entirely of firms building additional factories and office buildings. So this $100 billion of investment in factories and office building is going to cause the construction of factories and office buildings to increase by $100 billion. It's, by definition. So what we're going to see is GDP will also increase by $100 billion. Now remember that increases in production are going to result in equal increases in national income. So this increase in real GDP of $100 billion also increases the national income by $100 billion. Again, this is just by definition because they equal each other. So in this example, the income that's received, this income is received as wages and salaries by the employees of the construction firms, people actually building those factories and office buildings, and as profits by the owners of the firms and so on. Now after the construction workers and the owners of the firms receive that income, additional income that they weren't receiving before, these workers, managers, owners, whoever, are going to increase their consumption of cars, appliance, furniture, all these other different products in the economy. So let's say the marginal propensity to consume for these individuals is 0.75. So if we've increased national income by $100 billion, 75% of that is going to be now additional spending. So now $75 billion, so 75% of the $100 billion, is going to be increased consumption spending. So now this additional $75 billion in spending is going to cause firms that make the cars, appliances, all those other products that people are buying to increase production by $75 billion. So GDP is going to rise by $75 billion in the second period. Imagine the first period, or the first round, is that additional investment. The second round is then those people consuming. So they take 75% of that initial $100 billion and begin spending it. So there's $75 billion additional expenditures. So that's going to cause those firms who they're buying from to increase production by $75 billion. So GDP is going to rise by $75 billion. This is going to increase national income by $75 billion. Again, by definition, because this money is being spent. What is this $75 billion going to do? It's going to go to the employees of those firms and the owners of those firms that are now having additional goods being purchased by them. Those workers and those owners of the firms, in turn, are going to increase their consumption spending. And 75% of that $75 billion is $56 billion. And we're going to see this over time keep building up and building up. So 75% of each of these additional expenditures in each round are going to be spent by the owners of the firms and by the workers in those firms. And it's going to continue until we've exhausted all those gains. So in this case, as we get through 19 rounds of this, we'll end up with still $1 billion of additional expenditures, but our total increase in GDP is going to be $398 billion. So now we don't know how long it's going to take for this adjustment to macroeconomic equilibrium to occur. So using the idea from the previous slides, we don't know how many rounds it's going to take, how long it's going to take until this happens. But we know this is how the process is going to shake out. But what we can do is calculate the value of the multiplier. So we can take that as the eventual change in real GDP divided by the change in autonomous expenditures, or the planned investment. So in this case, we'll set up the change in Y, the change in real GDP, divided by the change in I, or the change in investment spending. So for this previous example, the change in real GDP was $400 billion, and the change in investment spending was $100 billion. So by increasing investment spending by $100 billion, we ended up with $4 billion of additional real GDP. So in this case, the multiplier is going to be change in real GDP, 400 billion, divided by the change in investment spending, 100 billion. So it's going to equal 4. So we could say our multiplier is 4. What that means is each $1 increase in planned investment, or in this case, any other autonomous expenditure, eventually is going to increase equilibrium real GDP by $4. The multiplier isn't always a positive thing. Sometimes, in some rare situations, you can experience a negative multiplier. So during the Great Depression in the 1930s, what we saw is the multiplier working in reverse. So on August 29, the economy reached the business cycle peak. Soon after that, there were several negative events, including the stock market crash of October 1929. So both consumption spending and planned investment declined afterwards. And then after Congress passed the Smoot-Hawley tariff in 1930, there was a trade war between us and other nations that significantly reduced our exports. After that, there were waves of bank failures that began in the fall of 1930. So there were a lot of problems in the macroeconomy that we were dealing with at the time. So as aggregate expenditures began to decline because of all these problems, many firms experienced declining sales and began to lay off workers. So as we experienced these falling levels of production and income, this induced further declines in consumption spending, which led to a negative cycle, a vicious cycle of further cutbacks in production and employment, and lower income leading to further cutbacks in employment and production. So the bottom of the page or bottom of the slide here, we see the negative spiral in action, comparing the peak of the business cycle in 1929 to 1933. So consumption fell from $781 billion to $638 billion. This is a pretty substantial drop. You see overall real GDP fell from $1,057 billion to $778 billion, as the unemployment rate swelled from 2.9% to 20.9%. So we can use that 45-degree line diagram, the Keynesian cross we've been talking about, to illustrate the multiplier effect working in reverse during these years in the Great Depression. So the economy was at potential real GDP in 1929. This was before the declines in aggregate expenditure began. Then we started experiencing the declining consumption, planned investment, and net exports, and that shifted the aggregate expenditure function down from the line AE 1929 to AE 1933. And what we saw here is equilibrium real GDP fell from $1,057 billion in 1929 to $778 billion in 1933. And it was the depth and the length of this downturn that led to it being labeled the Great Depression, because of how bad it was compared to previous depressions. So table 12.4 that we looked at a few slides ago shows that during the multiplier process, each round of increases in consumption is going to be smaller and smaller than the previous round, as some of that money is being saved while most of it is being, spent again. So eventually the increases from increasing this autonomous spending is going to come to an end, and we'll reach a new macroeconomic equilibrium. But you may be wondering, how do we know when we add all the increases of GDP, the total spending will be $400 billion for that example? So we can verify this by first writing out the total changes in equilibrium GDP. So it's equal to the initial increase in planned investment spending plus the first induced increase in consumption plus the second induced increase in consumption plus the third induced increase in consumption, and so on and so on. Eventually this becomes an infinite sum, and how mathematicians write it is instead of 1 plus MPC squared plus MPC to the third, going all the way to infinity, we can write it as 1 over 1 minus the marginal propensity to consume. Now in our case here, the marginal propensity to consume is 0.75 or 75%. So the multiplier here is 1 divided by 1 minus 0.75. That's going to equal 1 divided by 0.25, which is going to equal 4. Again, this gets us to the same answer we had before. So a general formula for our change in multiplier is the multiplier equals the change in equilibrium real GDP divided by the change in autonomous expenditure, which again can be written as 1 divided by 1 minus the marginal propensity to consume. Now, knowing where this math comes from or how we derive it isn't the most important thing, but it's still worth it or worthwhile for me to show you guys exactly where it comes from. So you know this formula isn't being pulled out of the air, that's actually coming from something. But it's not actually calculating the formulas that's important. It's being able to work with it and understand the implications of these formulas and being able to apply them. All right, so let's summarize the multiplier effect. These are the 4 main points I want you guys to take away from the multiplier effect. So the multiplier effect occurs when both autonomous expenditure increases and when it decreases. So it can be a positive thing or a negative thing. So for example, with a marginal propensity to consume of 0.75, a decrease in planned investment of 100 billion will lead to a decrease in equilibrium income of 400 billion. So we're getting the same exact effect, just the opposite. So if we had an increase in planned investment like we worked with before, we're going to increase equilibrium income by $400 billion. But the opposite is going to occur when there's a decrease in planned investment. The multiplier effect is great for the economy when we're increasing these planned investment, when we're increasing one of the expenditures that goes into real GDP. But it's going to be a bad thing when we're decreasing one of those. Next is that the multiplier effect makes the economy more sensitive to changes in autonomous expenditure than it would otherwise be. So, for instance, between the fourth quarter of 2005 and the second quarter of 2009, so during the financial crisis itself, spending on residential construction declined by 57%. So this is like over half of spending. So this decline in investment set off a series of declines in production and income and spending and all these other sectors of the economy. So decline in spending in residential construction had an effect, a rippling effect throughout the rest of the economy. Next is the larger the marginal propensity to consume, the larger the value of the multiplier. So the marginal propensity to consume is 0.75, the multiplier is going to be 4. But the marginal propensity to consume of 0.5, the multiplier is only going to be 2. So because there's this direct relationship between the value of the marginal propensity to consume and the value of the multiplier, it's going to hold true because the larger the marginal propensity to consume, the larger the change in consumption that takes place after each change in income during the process, which is why we get this larger number. And finally, our model is somewhat simplified, so it's going to omit some real-world complications. So like the effect of increases in GDP has on imports, on inflation, interest rates, individual income taxes, a lot of things like that. So with all these effects, when we combine them, it's going to cause a simple formula to overstate the true value of the multiplier. Now, while it's not going to be perfectly accurate, it still gives a really good understanding of what's going on. It helps us understand how spending in one sector of the economy is going to have, a rippling effect throughout the rest of the economy. And that's something, again, that's really important. And it helps us understand what's happening with the macroeconomy. So remember earlier we talked about the savings identity, that savings equals investment. So all the money saved in the economy by households and by the government is going to equal the investment, the total investment in the economy. So what we took away from this is that savings were key to long-term growth. But John Maynard Keynes noted a problem with this. And what happens in the short term if a lot of people decide to save more? A lot of households decide to forego consumption in the short term and decide to save so that they could spend more in the long term. When consumption decreases in the short term, income is going to decrease. So consumption decreases. So potentially we can push the economy into recession. We can end up with that downward spiral I talked about, like from the Great Depression earlier, occurring just because more households are deciding to save. And Keynes called this outcome, this idea, the paradox of thrift. Because while thrift is a good thing, while saving money for the long term is favorable for long-run growth, it may be counterproductive in the short run. Now there's some debate among economists whether the paradox of thrift really exists, whether it's a problem that, while it could occur in theory, whether it's actually going to cause a problem in practice. increasing savings does decrease the real interest rate. And the consequent increase in investment spending may offset the decrease in consumption spending. So in practice, we're not sure what the effect is going to be. It's ambiguous whether Keynes's paradox of thrift is right and we're going to see declining incomes, or whether we're going to see that be neutralized by the increase in savings. And using our simple model, we're not going to be able to, find evidence of the paradox of thrift, whether it's true or not. So now let's briefly end by talking about how a change in the price level affects the aggregate expenditures. So when demand for a product increases, we expect that two things are going to occur. Production is going to increase, and so will the product's price. Remember back to our supply and demand diagrams. When the demand curve shifts to the right, we see an increase in the quantity demanded and quantity sold on the market, and increase in the price that's being sold at. So in the larger economy, we're also going to expect that an increase in aggregate expenditure is going to increase the price level. So what effect is this price level change, this increase in the price level, going to have on aggregate expenditures? We generally expect that there will be an effect. That increases in the price level are going to cause aggregate expenditures to fall because households' relative wealth is now decreasing because the cost of living is increasing while their salaries are staying the same. Conversely, decreases in the price level are going to cause aggregate expenditures to rise because now households feel relatively more wealthy. Their dollar can go further, so they're able to purchase more. Now the two figures on this slide highlight what I just mentioned on the previous slide. So the first figure on the left, an increase in the price level, is going to cause aggregate expenditure and real GDP to fall. Aggregate expenditure is going to fall because as the price level increases, the amount of goods and services households can consume is going to decrease. Again, because the cost of living has increased. On the other hand, decreases in the price level. So as the prices of goods and services fall, households are relatively more wealthy. They can afford more than they did in the past, even with the same salary. What that's going to do is shift up the aggregate expenditure curve, and it's going to increase real GDP. Now this is a little bit of a preview of the next chapter. But because of what we just talked about, there's an inverse relationship between the price level and real GDP. And this inverse relationship between the price level and real GDP is known as the aggregate demand curve. The aggregate demand curve is a curve that shows the relationship between the price level and the level of planned aggregate expenditure in the economy, while holding constant all other factors that might affect aggregate expenditure. So it's basically the demand curve we've talked about very early on in the course when we were looking at like individual firms. Now we're looking at the economy as a whole. So instead of just demand for one product, it's the aggregate or total demand. But we're going to be graphing this with the y-axis of the price level, or before the price, and the x-axis of real GDP, or the quantity, before. And in the next chapter, we're going to work with the aggregate demand and aggregate supply, just like we did with the market demand and market supply for a particular good or service.